We are going to do the ball zigzag demo here. There will be two participants, myself and Mr. Hill. I'm going to have the more massive bowling ball. Mr. Hill is going to have a less massive basketball. Our challenge is to go from having our balls all the way left, go a full 180 degrees, and then back, and that's each going to be 1 point if you want to say, and we're going to see how many points we can get in 30 seconds. Okay?
You got enough room, Scooter, or just a little left? All right. On your marks.
Get set.
Go. Get it longer.
Elbows are burning. Stop.
And stop. Oof. All right. How many did you get?
I got 20.
I got 32. Nice job.
Crushed me.
All right. Hello everybody, I have the Alieneers here to demonstrate one of Newton's laws. Let's get these guys going.
So here we're going to do paper blowing. All I'm going to do is take a regular piece of paper and blow over the top of it. See what happens.
This is called big ball, little ball. We're gonna drop the basketballs touching each other from about a foot and record its motion, and then we'll do the same thing with the basketball and the tennis ball. Here we go. Going?
Yep. Here we have the inertia block. There are two identical strings, one hanging from the bottom of the inertia block down, one hanging from the top of the inertia block and then securing it to this hook here. What I'm going to do is first, I'm going to pull on the bottom string really quickly. And we're going to observe which string breaks. Either the top string will break, either the bottom string will break or the top string will break. Then, I'm going to do the same thing, only I'm going to pull slowly. And we'll see if there's a difference. So here, I'm going to pull really fast on the bottom string. And as you can see, the bottom string broke. Okay, now we're going to do the same thing, only this time, as opposed to pulling fast, I'm going to pull slowly. And in that situation, the top string
watch it get down low. Okay, let's try this again. 1. What are you doing?
Here we have just a standard hair dryer and a standard ping pong ball, but they can do some pretty unstandard things.
Phone book wrestling. We have 2 interlaced phone books, page by page. No glue, no tricks. Normal phone books. And me and Mr. Locker are going to try to pull them apart. Grab that side.
Ready?
Take a grip. Get low. Go. The shoes. Oh. I don't think it's working, Mr. Locker. Did it move?
Nope.
Try one more time.
Pull harder.
Oh, come to pop. Nope. No love. All right. Now we should just leave it like that with the phone book sitting.
So what we have here is a standard aluminum pie pan and a ping pong ball. What I'm going to do is send the ping pong ball moving around the pie pan. And what we're interested to see is what happens when the ping pong ball leaves. Will it shoot off to the side? Will it go this way? Will it go straight? And we will be able to observe its motion by which of these dominoes it knocks down. All right, ready? Fail.
Three, 2, 1.
We're going to do collisions. We got a track here. I have a 1 ball, a cue ball, and a steel ball bearing. The steel ball bearing is a more massive ball than the 1 ball. It has more mass, it's smaller, but it has more mass. Collisions. We're going to drop the cue ball from the same height for the first experiment. Now we're going to replace the 1 ball with the steel ball. Remember, the steel ball is more massive. Drop the cue ball from the same height and observe. This time we're going to do the same experiment, except we're going to leave the colliding ball and the ball being collided with the same and change the height in which we drop the cue ball. So we'll start from a lower height on the ramp. And now we'll go to a higher place on the ramp with the cue ball. Collisions.
And this would be the last one, number 10, that might be left blank on your handout.